Hi everyone and welcome to this new video. In this video I will show how you can use Python, the programming language, to generate HTTP requests. So we're talking about generating HTTP traffic programmatically through Python, the language, and specifically using the request library. So I will showcase how to install the request library through the Python virtual environment. And then I will show different examples where you can generate a GET request or POST request with different sort of characteristics. And at the end, I will showcase a practical example on an application of this ability. So why should it be useful to generate HTTP requests programmatically? That is the question I want to answer with this video, and to argument why it is a useful skill to have, I will show an example taken from the DEM vulnerable web application where we will brute force a login form using Python. So the idea is that, consider this, here I have the usual burp suite setup. Here I can eliminate this request because we don't care. And here I have the DEM vulnerable web application login. I already showcased this application in my web exploitation series. But the idea is that here there are a bunch of different modules. For example, there is the brute force module. Now, as we use this web application with the browser, like if I go into command injection, CSRF, like brute force, here I can test a username and password. So as I use the web application, the browser makes a bunch of different HTTP requests. And this is how the main flow of data is transferred between the client, which is the browser, and the server, which is the web application, in this case, the DEM vulnerable web application. So here with burp you can see this traffic. For example, we started with a post request to the endpoint /login.php, and here we have a form data. So we have username, password, login, user token. This is for CSRF protection, and here is the response of the server. And as you can see here, I make a bunch of different requests. So with Burp Suite, I can capture the HTTP traffic that is generated by the browser. However, this HTTP traffic, as I said, is generated by the browser. It means that we have limited control over what we can output like this. For example, here I can test a bunch of different logins, and for each different request, for each different attempt, like user 1, password 1, user 1, password 2. So for each different attempt, I generate a different HTTP request. So the ability to skip over the browser and go directly to the HTTP traffic is actually pretty useful, because I could use this as a sort of basis to build a web fuzzer, to build something that scans for vulnerability given certain requests. I can do a lot of different applications using the same ability, which is that of generating HTTP traffic using Python or any programming language, really. This is not limited to Python. Python is just a simple and powerful tool because of its simplicity, because it's really straightforward to use, but you can use other programming languages. You can use C, C++, Go, Rust. You can use all sorts of languages to do this sort of job. So let's get into the details. Now, how do we install the library? So the idea is to create a virtual environment which will wrap all our dependencies and libraries that we use. This is really useful to do because it allows you to have a clean management of dependency. Sometimes it breaks, but typically it works fine. So how do we do that? Let's open a shell here. I'm going to go into source. I'm going to eliminate the previous environment that was there. We don't care about that. And I'm going to eliminate the requirements because we will recreate them to show you. So we start off by doing python 3-m vm. So this command says create a virtual environment and name it vm. So the first VM is to signal a new virtual environment. The second is actually the name of the virtual environment. I typically go with VM because it's simple. Then we need to activate the environment. We can do that with .vm bin activate. Now notice that the prompt has changed because now it signals that, look, the VM environment has been activated. So now all dependencies that I install with pip do not go into the system dependencies of Python, but rather to the current directory, to the current virtual environment that I'm working on. And indeed, if I search for pip3 and for Python 3, notice that the path here is of the current directory, not the system-wide directory. So the only dependencies for this video is the request library here. So we can take this command and we say pip3 install request. Now what is request? Request is a Python library that allows us to generate HTTP request and allows us to read the HTTP response of the server. Because remember, one thing is to generate the request, which is already very useful to do. But another thing is to take the response of the server and to extract its various elements. For example, the status code 200, the HTTP version, the response headers, and the response body. So we want all of these different elements. So once we have installed the library, this thing I do it for maintenance, sort of. The idea is that we want to obtain a list of dependencies for the current project. We can do that with pip3 freeze. Here we have a list of dependencies, and then we can standardize, like we can pipe it out, we can write it into a file with requirements.txt with the redirect output to the file, so that in requirements.txt now we have a list of all the dependencies, and next time we're just gonna commit this requirements.txt in our version control system. So we're gonna do git add requirements, for example, and next time you can just do pip install r requirements. If you do this, you're only gonna install the requirements specified in that file, which is extremely useful. So at this point we can see the actual code on how to use the request library. So we can create a file named examples.py. So this is gonna be our first thing. So here I'm gonna put a shebang, which simply tells where to find the Python 3 interpreter. Then I import the library, which is called request. And then here I put this sort of like setup. So it's if name equal main, then you call the function main. So this is a guard, a sort of guard statement that is only true when we call this Python module from the command line as follows. When we do, for example, Python 3 example. So let's put a hello world here. So hello world. Then I call here, and notice I get this. Because what happens is that sometimes we can also import this code as a Python module. In that case, this main is not going to be executed because this variable name is main only when we execute it from the command line. So this is just to clean up the project. So it's very useful to do. So at this point here, I'm going to have three different examples. I'm going to have get examples, so now to generate get request, post examples, so now to generate post examples, and then response examples on how to read the response from the server. So for each of these, we're going to do define and then pass, because we still have to implement them. We're going to start with the simplest get. So these are the three examples we will see, and this will just showcase how to work with the library. Now, a useful thing is that since I have burp here, the idea is that we want to proxy all the requests that the library makes first to burp suite and only then to the server of destination, to our destination. So how do we do that? We define a dictionary on the top level that works for two protocols, HTTP, so this has to be lowercase, and here we put the endpoint of the proxy, and then HTTPS. So we put this, and when we use the library, we will say, look, use this proxy for the protocol HTTP and for the protocol HTTPS, and the request will automatically use that proxy. It's just that in each function, we just specify the global variables. That's it, pretty simple. Now at this point, we are ready to use the request library. How do we use it? Now to perform a simple get, consider a given URL, for example this, localhost/get. This is a valid URL. Here we have protocol, we have the domain, which is localhost, and then we have the resource path, which is /get. Then we do request.get. So here we are saying, look, I want to make a get request. So here we are talking about, of course, the HTTP get request. Because the HTTP protocol has different verbs, each verb specifies a type of action. There is get, there is post, there is put, there is patch, there are a lot of different, there is trace, there are a lot of different verbs. In this case is, look, we want to generate a get request. Now, this function can take many different arguments, and the arguments go to specify exactly how this GET request should be structured, what kind of headers, what kind of data, what kind of parameters, and stuff like that. For now, we just need a URL, which is the simplest thing, And then, since we want to proxy all the traffic into the proxy of our choice, we do proxies equal and then this dictionary. So if we just do this, look what happens. So look at this. Here I'm gonna delete all of the stuff here, and then I'm gonna open the command line below. So I'm gonna execute the script, and notice here what do we get. We get a /get, a method get. So this is the request that has been generated by the request library. As you can see, there is a user agent Python request 232.3. So it also tells us the version of the library. Pretty useful, pretty cool. So the idea is that by writing this simple code, we were able to generate this request. Now, to actually understand the power of this, though, this simple example is not enough. Why? Let's do a more complex example. So this is just a simple get. Let's do a get with custom path parameters. So what does it mean? It means that the URL can have different parameters. So let's put a different base URL. But now we want also custom parameters, params, and this we're gonna specify with a dictionary. So we have key1 value 1 and key2 value 2. And then we're gonna do request.get, also the URL, but this time we're gonna do params equal custom params and then proxy equal proxies. So now we're gonna send two different requests. Notice this. We have the previous one at get, which is the simplest one, and then we have this with /params. Now notice that this request at /params actually contains two parameters here, and the first parameter has name key1 and value 1. The second parameter has name key2 and value. Actually not value 2, let's put value 2 here. Let's save, execute again, and check here. And the second parameter now is value 2. So it means that whatever we put in this dictionary will be encoded into the HTTP GET request as a path parameter. So as a parameter that goes in the URL. This is called a path parameter or URL parameter, however you want to call it. But the idea now is that we can use Python code to generate the value of those parameters. So for example, let's say that we want to iterate a value from 0 to 10. Remember that the range in Python is exclusive on the right side. So this is going to be from 0 to 9. And then here we can do index equal and we put the value I. And that's it, right? So how many requests are we going to generate? Well, we're going to generate 10 different requests. Here I'm going to clean the stuff. Look, I'm going to generate 10 different requests and each of them is going to be a different index value. So now we have all the power of Python, all the programmatic power of Python, and we can embed this into the generation of HTTP traffic, which makes this extremely useful. So we can go back to the previous dictionary, which is very simpler, and this just goes to show this. So let's see other things that we can do. Well, for example, we can change the headers, right? So the headers specify extra information in our GET request. Well, we can do, once again, we can do GET with custom headers. So the structure is gonna be the same. Custom headers, we're gonna put, let's put content. Actually, so notice this. The user agent is a very simple way that the web server can use to understand who's making the request. Now here it says Python request, but if I make a request with the browser, so I'm gonna do the request with the browser, notice here, the user agent is a bit more complex. So one of the simplest way in which you can bypass controls over who's making the request is by just taking the exact same user agent that the browser uses. Of course, this is very trivial, like checks based only on the user agent value are really meaningless because we can modify it as follows. So user agent, and here we put the value of the browser, and then we do request.get URL headers equal custom headers, proxies equals custom proxy. Gonna delete this so it's more clear. I'm gonna make the request. Notice we have get params with so let's do header. So let's do header here. And so here I'm gonna order them by this. And notice here, now the user agent is not anymore Python request, but it's the exact same that the browser makes. And this is why protecting with respect to client-side traffic that has specific user agent label is simply not enough. You need more sophisticated techniques for fingerprinting clients, like TLS fingerprinting, for example. But the idea is that basing only on the user agent is pretty meaningless. So this just to show that you can essentially put any header you want. You can put header computed through different functions. Now you just inherit all the computational power of Python into the HTTP traffic. And of course, here I've made two different requests, but you can also combine them, right? So you're going to do get with custom headers and custom path parameters. We just combine this. You're gonna get this from here. So you're gonna get this from here. So you're gonna get general, and then you have custom headers, custom params, and then you put params equal custom params, headers equal custom headers, and proxies equal proxies. You make the request. Let's clean everything. You make the request, and the last request we will make will have the specific custom user agent here with the path parameters, key 1 value 1, key 2 value 2. So this is a really simple example with gets, with get verb, just to show how easy is the library. It all works with dictionaries, and you have specific keywords here. These are called optional parameters because you can have them and you can also not have them. Like for example, you can also say a request to get URL like this, but the problem is that at that point we wouldn't see it in burp, so we wouldn't be able to debug it, let's say. So we always want proxies to debug, but if you don't have to debug, you can skip the proxies parameter. And so the idea essentially is that depending on your specific use case, you will generate the HTTP traffic that you need. And we will see a real practical example at the end of this video where we will analyze how to brute force this login, how to do this vulnerability brute force module of DEM of DVWA with Python programmatically. So that's the cool thing. So continuing with the post example, now the idea essentially is the same. It's just that now we have not request.get, but rather request.post. So here we have a simple URL, localhost post. Then we have request.post URL and also proxies equals proxies. So if you go here, notice here we have a post. Notice here, this is now a post. It's not a get anymore. It is now a post. So we change the verb. And of course here we can also put like put. We can put also proxies because otherwise it's not gonna be proxied. We can put a put here. We can do a patch. All the verbs that are supported by HTTP. I'm not sure if we can do a custom thing, XXX. No, because we cannot do a custom verb. So we are limited in the with respect to this, but it's okay. I mean, if we want to do a custom verb, we can use burp. We can do this, and it's gonna say not implemented and stuff like that. So in that case, Burp Suite is more is a better tool for the job. So the idea is that we have a simple post. Then we can have post with xwww form URL encoded body. So a post with a specific body. So we're gonna do the same structure sort of. It's just that now we have form here. So this is gonna represent, for example, the output of a front-end form. When we find a form here, so let's say I do go into intercept. Here I write admin and password. I do this. Notice that this is sort of like the result of a form. Now here, the value are passed as get parameters, but if I change the security, to medium, I believe that in this brute force, they're gonna be passed also as this, so it doesn't really change. But if we go into the outside, into this form, I do admin password. Now notice now that the parameters are passed as a content type application /x www form URL encoded. So this is the result of a form. And if you go here, the form is this. So this is the end of the form. This is the login form, which contains a label for username and a label for password and the typical submit button. So anytime you have a form like that, you will have an HTTP request that is sent that has the same structure, sort of. It has content type xwww form URL encoded, and here you have the parameters. So we can generate the same thing in Python. How? Well, we're gonna do once again custom body params. I'm gonna say key 1 value 1, key 2 value 2, and we're gonna do request.post URL, and then we do data equal custom body params, and then proxies equal proxies. And with this parameter data, we're gonna put stuff in the body. So let's go into the request. Let's delete everything to make sure we actually read it, and let's execute it. Notice now that we have this form. So this form actually, okay, this one, it's this one that we're interested in, is post form, content is application slash x www form URL encoded, and here we have all the data, key 1, value 1, key 2, value 2. We are essentially simulating the submission of a form. Now, don't worry about this not found, because in the application, the slash form is not really present, but we don't care. We're just focusing on understanding the mapping between the Python code and the relative HTTP request that is generated, because that's essentially the idea. So this is a post with this kind of thing. So if you want to do, for example, a post with custom headers, it's the same thing as before. It's just that now, so we can call it post headers. We can take custom headers like before, but now we do request.post and headers equal custom headers. So we do like this. Let's clean here the traffic, and then I'm gonna send it again. And notice here at the end, post headers. So we have a post slash post headers with the user agent that now is custom. I change it to my liking. Here I could put also XYZ just to show that I can control it. Let's generate traffic again. Notice here is the user agent XYZ, so we can have full control over that. Finally, in terms of post, I want to show post with JSON body. So what if we have a body not in a URL encoded but in JSON? So we do JSON. Here we have custom JSON body. So we can actually copy the body because the stuff is the same. It's just that the encoding is going to be different. We do request.post URL JSON equal no more data. So we don't do data equal. We don't do it like this, but rather we do JSON equal and then the same as before. Proxies equal proxies. And notice this. We're gonna clean all the traffic here. I'm gonna send it again. And look at this, slash JSON. Notice right now is content type application JSON, and we have a JSON as the body. So this is the end of the post example. We show how to make a simple post, how to make a post with the URL encoded body, which is a typical form submission that is generated by the browser. Then we have post with custom headers, essentially the same as a get with custom header. It's just that now we have request.post, not request.get. And finally, we have a post with a JSON body. So the final example before the real practical example, where we're gonna put all of this into practice, is, okay, this is how you make a request, right? But after you sent the request, the server is gonna reply with a response. So there is the HTTP request, which is generated by the browser, and we show how to generate them with Python. But now we have to deal with the HTTP responses, right? So how do we do that? Well, it's pretty simple actually. So let's go back to a simple get example. So we're gonna do global proxies. You're gonna do URL http localhost index.php. So let's try to make a request to the website. Now, when we make a request to the website, we have the concept of authentication, meaning that we need to authenticate our identity. Now, in the web, this is done with different ways. You have, for example, JSON Web Tokens, but you also have session cookies. So, for example, in this specific case, here the cookie php is used to actually control the authenticated session. It means that when I use this cookie, when I bring this cookie to the server remembers that I'm authenticated, and so it shows me the authenticated version of the website. Now notice what happens if I put this into repeater and I strip the cookie. So here I want to change this like this, and I strip all the cookie header. It's gonna say, look, okay, 200 okay, but this is not the authenticated version. Here I do not see all the modules of the application. So it's a difference here. So how do we do that? Well, we just have to add a cookie with the value php and this value we can take it right from the previous request. So either from here, from the previous request, so like this, or we can also take it directly from the browser. We do Ctrl-Alt-I, we do application php this value, we do copy. This is the cookie in the cookie jar of the browser, because of course the browser has to store the cookie somewhere. So this is our value. So how do we use this? Well, the idea is that we're gonna make a custom headers dictionary. It's gonna be called cookie. It's gonna have the value of a format string php.std equal. Then I'm gonna put this thing, which is a format string. It is a way to build strings in Python. Then I'm gonna do semicolon security equal low, because security is another cookie. Then I make the request, so request.get URL headers equal custom headers. Now at this point, I've made the request, so I can also do proxies equal proxies. So at this point, I've made the request. So if I remove everything from here, I have it here, I'm gonna execute it. Notice that at the end, I get this index.php and I get okay, I get the authenticated version, perfect. But now I want to read the response, right? So the idea is that the output of the request.get method of the request.get is actually the response. So it contains all the data of the response. So I can do r.status code and I get status code. I can do r.headers and I get response headers. I can get r.headers server to get a specific header, server header. I can do r.text to get response body. So to get response body. And then I can like print all of this stuff. So I can print status code, for example, and I get 200. I can print response headers and I get all the response headers. So we have date, we have expires, we have content type, and stuff like that. We have also the server, right? So server Apache 2. So if I do into server header, I just get Apache 2.4.25 because this is another dictionary. So the idea is that the request library uses dictionary to prepare the request and then reads the response and parses it into other dictionaries. So it's all a dictionary. And of course, the most important part is the response body, which we access with r.text, because the response body contains the entire HTML that the response contains in the body. So instead of having visible like here essentially, so let's do a request where you can see it. Like essentially it's this stuff, it's all the body, the HTML. So it's all this stuff that we can access also with Python. So we have access to the response, to everything about the response essentially. So for example, if we want to do a check condition, we can do like simple welcome to them vulnerable web application in response body. So this is like a check if we are properly authenticated. And if we execute this, it's gonna say true. Why? Because let's take this string. So let's take this string. I go here, I pass it here. And notice that it gives us this string. But if the same string, so this is when we are authenticated, right? I get it. If I remove the authentication cookie here now, I don't have this string anymore. It doesn't find it. So it has found to the login, I believe, or what? Let's see. So this is the non-authenticated version, and I don't see anywhere this string. So this essentially tells us if we are authenticated. So this is it when it comes to this simple example on how to use the request library. Now we are ready for a practical application. We will take the brute force module, difficulty low, the first difficulty, and we will solve it only using the Python language. So this is so no response found. Maybe what happens, I don't know. I don't know what happens. Maybe the proxy or something maybe. Okay, now it works again. So we find this module and we will solve it with Python. Okay, so for the actual example of how to use this request to do something useful, because so far we just saw how to use the library. Now, how can we actually apply the library to a real world example, to something that we would want to do? Consider this login form. So when we execute this stuff, it says username or password is incorrect, and our objective is to find a credential that allows us to enter into this login. This is a typical brute force problem because we don't have to do like magical stuff. We just have to make many different HTTP requests, each request with a different set of credentials until we find the correct one. When we find the correct one, we will not see this message, we will see a different message, and therefore we will know that they are the correct credential. So how can we do this? Well, remember, as I said, that all the traffic we see, it's not magic, it's just HTTP. So here is an example request that is made. What we can do is we can take it, we can bring it into a new script called login.py. and we can just try to generate with Python, but we don't want to generate the same exact request. We want to generate the same template, and then we want to iterate over the username and password parameter field here, URL parameters, until we find the correct one. So as always, I start with the shebang and with some just comment line to separate this, and then I do import request, and then down I have the guard on the main, and here I have the main. So here I have the main. So this is gonna be the main code. So what's gonna do the main code? The main code is gonna call a bunch of global variables that we have to define: username word list and password word list. So this is gonna contain word list, so path to word list. So this is gonna be equal to something. It's gonna be equal to something. It's gonna call data username.txt. And here we can do data passwords.txt. And then here we have the proxies. So we have HTTP, HTTP localhost, and HTTPS, HTTP localhost. So the proxy tab, perfect. And then we can also put as a global variable the PHP SSID value, which we can extract from this request. Perfect, so these are all the global variables. So now the username word list and the password word list are just list of usernames and passwords that we will use to sort of like do this attack. Here I have them prepared, so they are in data. So we're gonna do data. For example, usernames, I have admin, Bob, Leonardo, Francesco. Passwords, I have password, admin, password 123. I mean, you can imagine them to be like super, with a lot of different passwords and username, super big, like megabytes, a lot of megabytes, hundreds of megabytes. And of course, you need to be able to generate all this traffic, of course. But the idea, that's the idea. So what we're gonna do, first we're gonna read those username and word and passwords. So we're gonna say read the word list, and we're gonna put, of course, the username word list, and then same thing for the passwords. So nothing fancy, just gonna read this stuff. Of course, read word list, we have to define that. So we're gonna define that, and we're gonna define it later. For now, it's just a stub. Once we read all the username and passwords, we have to iterate them. So we can do a print, info, loaded, len usernames, len passwords. So I'm just gonna print them. For user in usernames, for password in passwords. So I'm gonna iterate over all the possible combination of username and password. If check credential, user, password. If this function is true, this is the main function which will check if a given set of credential works or not. So here we will abstract away the making of the HTTP request. So if this is gonna return us true, then it means that we found the credential. So it means we can print like found credentials, and here I'm just gonna print them. So I'm gonna do user, password, and here I'm gonna just do like that. And then if so if it's not true, we just continue. If we found a credential, we can just do break, because at this point we don't need to try anymore for this specific user. So we can just skip to the next user to try to break the credential for that user. Here we can a break is good because a break just exit from the internal loop. So we do the next iteration of the external loop. So, but to use this code, we need to implement these two functions. So the read word list is pretty simple. We're just going to do return open. So here I have a word list path. So I'm going to do word list path. I'm going to do in read mode, I'm going to do read, and I'm going to do split lines so that I have a list for every new lines. So if I just do this, and I just print them just so that you can see usernames, and then I'm gonna do Python. So let's open here maybe. Gonna do Python login. So I've loaded 4 username, 3 password, and these are the username. So it's a list of values, simple list of values. So this is it. This is the first thing. And now at this point, the check credential. So the check credential is the most complex one, of course. We have a bunch of global variables. We have the PHP SSID and the proxies. Then we have the URL. So the URL, now the URL, we can obtain it from the request. So the host is localhost. So we're gonna do URL equal HTTP localhost, and then the path is this vulnerabilities /brute. So we don't put this stuff because this stuff is the URL parameters, it's not the path itself. The path itself is this. The domain localhost, the protocol is HTTP, and we have /vulnerabilities/brute. So this is important to know. Then we have the custom params, so our custom parameters. In this case, we have username. We have, and here we have a bunch of stuff, password, and then here we have a bunch of stuff, and then we have login. The value for login is always login, right? But the value for username and password, in this one it was asked, but we actually want to change it, right? So here we take two like parameters, username and password. We can say user and password. And so this is our custom parameters. And then we have custom headers, of course. So we're gonna have the user agent, we're gonna put the one from Chrome, and then we have the cookie value. We're gonna put the format string with php_id equal the php_id global variable, and then the security equal low. And this user agent, we can just print this stuff. So user agent, this one, Mozilla, we can do copy, and we can put it here. So we can actually intercept this, we don't care. So at this point, we have all the stuff that we need. So how do we prepare the request? We do air.request.get, the URL, headers equal custom headers, params equal custom params, and then proxies equal proxies. And this is our request. Now, to actually check programmatically if we enter or not, what we can say is, if we have this return, so this string, in air.text, if this is return, it means that we did not enter, so we have to return not of this condition. Because this condition happens only when the credential failed, not of this condition happens only when the credential succeed, so when we have a proper login. So let's try this. We're gonna execute it. And it says that it found a bunch of credentials. Now, it's too much in this case because it says admin password, but password. So let's see what's going on here. Let's see from burp in the HTTP history. So it says found. They did not say, okay, so this is a problem. So let's also make sure that the status code has to be 200. Status code, so how do we get the status code? We see example, the status code equal 200, and so let's do this. So also like this, maybe because it's a string. Maybe because it's a string. So okay, so in this case it fails for everyone. Why is it doing this? Probably because it is /brute, like this. No, probably because the cookie is not valid. Okay, notice here what happens. So if I debug this request, if I check the request it makes, okay, now it seems to make the correct request. Okay, now it seems to make the correct request. Admin password. Okay, it's good. And what kind of things? Okay, so wait a second. If I do print type of air.status code, is it an int? It's an int. Okay, it's an int. So I have to say it's equal to this and not this. Okay, so now it works. So now if I launch it, it says found credential, admin and password, because actually if I put admin and password here, I enter into the admin area. And so the problem was just to understand the type of the output. So because I was like string 200, but actually it's the integer 200. So the final code is not even that much. It's barely like 50 lines of code to brute force a login. And of course, you can apply this sort of logic to any situation in which you need to generate HTTP traffic. So we import the request, we define a bunch of global variables. The main loop reads 2 word list and iterates through all the possibilities. This is extremely inefficient computationally wise. It wouldn't work if we had to do like millions and billions of iteration. But in this case, it does work because there are really not that many. So we iterate through all the possibilities. For each possibility, for each credential, for each username and password, we check if they work. And here is where we abstract away the ability to generate HTTP traffic. So here we have the request code that allows us to generate the traffic that we use to understand, to just generate this thing brute force in a brute force way. So this is extremely useful to know. You can also do it with the intruder of burp, but in the community edition, the intruder is kind of nerfed. It's sort of like the powered, so it's not really that fast. But the idea is that with this, you can just generate any sort of HTTP traffic. So the video is long as it is. I hope it was enjoyable. I hope it was interesting. I hope you now understand how to make HTTP requests with Python and why it is a useful skill to know. So I hope it was fun. Leave me some feedback, subscribe to the channel, share with like-minded people, help me grow, and to the next video.